Okay, this is one of the type of CXC questions that you guys might be getting. So let's pay attention to this one here. Okay, so here we have a glass block, or the shape of a glass block, or a container where light is passing through. Please take note the direction the light takes. It comes in this, and notice it bends towards the normal, and so it comes out, and it comes out here. The light direction has been moved slightly. Okay, so you may be asked to label all of these parts or give explanation. Well, we know that reflection is happening here, refraction is also happening. So let's see. We know that from reflection, this angle must also be equal to this angle if we have reflection. So A and F would be equal, and so the refracted angle would be in here, and this angle must also equal to this angle C. Why? Because we have two parallel lines and a transversal, so we have alternating angles. Then we notice that the angle has increased because it went from one medium to the next medium, or it has emerged back. So therefore, let's label this diagram. Okay, A is the incident ray. So I'm going to be putting the answers in red. Incident ray, because it is incident there. B, with B, that's the reflected ray, because once it happens that it hits a surface, some of the light will be reflected. C, now this big C, is the refracted ray, because it has changed from one medium to the other, and so it has changed direction. D, now it is, now I want you to take note of this. This is now the refracted ray, but this refracted ray becomes incident at this point. However, okay, so if this becomes incident at this point, then we can call this also the incident ray, and this then would be the refracted ray. But because we're looking at one diagram, we're going to call this the refracted ray, and since the light ray emerged back into the original medium, we're going to call this emergent ray. So D is the emergent ray. Now E is the perpendicular bisector of this line, or what is known as the normal. We always have the normal. Okay, so that's for our labeling in that diagram. We also have some small labeling that we can do, so let's look at that. A is the incident angle. B is the refracted angle. C, this here would be the incident angle with respect to this point of incidence. So let's call this incident angle number 2 for right now. Incident angle number 2. Okay, so we can differentiate that this is incident angle from compared to this one here. Now D is the emergent angle. Why do we call it emergent angle? Because it is emerging back into the original medium. Emergent angle. E, now this, it has been moved laterally, so we call that lateral displacement. And F, which is here, that's the reflected angle, because we know the laws of reflection. So F is the reflected angle. Now here we have labeled all of our parts. Now you may get problems on this type of question. The questions that may come are as follows. These are the questions. So we're going to start with this piece here, looking at this diagram. Okay, so now we look at it. It states here, the refractive index of glass block is 1.5. Determine the value of angle F. In this case here, angle F, that's the angle we want to find first of all, when angle A equals 60, when this is equal to 60. Okay, so determine. So determine means you don't have to calculate it, just determine it. Well, A equals F equals 60 degrees. We all know the reason why, but a question may come up and they ask you to explain. State a reason for your answer in B. So why do we get this answer? Because the laws of reflection, not refraction, reflection. Okay, why? Because we know that there are two laws of reflection. The incident angle is equals to the reflected angle in the laws of reflection, right? Because the laws of reflection, which one in particular? Number 2, we can say incident angle equals reflected. Take note, reflected, not refracted angle. That's one of the laws. Calculate the value of B now. So what's the value of this angle here? Okay, well, according to Snell's law, let me fold this a little bit. We take note that they have told what is the refractive index of glass black. Once you've been given something like that, my advice, label your diagram. Okay, so I'm going to fold that page, and when I'm going to put here glass black to be 1.5, air is 1. Okay, now to calculate the value of angle B now, we know that Snell's law states the refractive index is equal to the sine of angle 1 over the sine of angle 2, which is incident and this is refracted. What is it that we have? Okay, so for us to determine this angle B, we must know what is angle A, which we were told to be 60 degrees. Sine angle 1 is equals to 60 degrees. N is equals to 1.5. They told us that, so we substitute into our equation. So we end up with 1.5 is equals to sine 60 degrees over sine angle 2. So let's go by rearranging the equation. We end up with that sine angle 2 is equals to sine 60 over 1.5. Okay, and then when we rearrange this, we end up with angle 2 equals to the arc sine of sine 60 over 1.5. Because you guys are using a scientific calculator, you can take that problem and work it out one operation with a calculator. So let's do that. So I'm going to turn this on, and I'm going to say I want the inverse sine. Okay, open bracket again, because I want to make sure sine 60 goes separate, of sine 60 close bracket divided by 1.5. Please take note, I still have an extra bracket, which is the big bracket. So I have small bracket here, and now I'm going to close it with a big bracket, and voila, that gives me the angle, which is 35.3 degrees to 1 decimal place. That's our angle B. Okay, if we had not put the inverse sign, the ratio would not be. Okay, so this is the angle that we are being asked, what is the value of angle B. Now what's the next question? Determine the value which angle B must exceed if D is to be totally internally reflected. Now here is where you have to think a little bit more. Okay, what happens here is that they're telling you, I want to know what must be the size of this angle for make this angle to be totally internally reflected. We know that the condition for total internal reflection, incident angle must be exceeded. Therefore, we need to figure out what is the incident angle. I mean the critical angle, sorry about that. The critical angle must be exceeded to have total internal reflection. So we need to determine what is the critical angle. Okay, so the way we're going to do this is as follows. We know that air is 1.0, we know that glass is 1.5. Okay, so for this to happen, okay, so let me just write what are the conditions for this to happen. For total internal reflection, critical angle needs to be exceeded. Therefore, we must determine first of all what is the critical angle. Determine the value which angle B must exceed. So we must determine what is that particular angle to answer this question. So the way you're going to do this is that you know that the glass block refractive index, this is a medium 1 because it is going from here, and then here will be medium 2. Okay. Snell's law now tells us that the medium 1 sine angle critical is equals to medium 2 sine angle 2, and we call this the critical angle because we want to figure out what is the critical angle in this one here, which is the second one originally. So this is just simply an angle, but we're going to call it critical angle because that is what we're looking for. So we need to rearrange this equation to get this angle by itself. We end up with sine critical angle is equals n2 over sine angle 2 over n1. Right? Now we know that the refractive index of medium 2 from the diagram is 1. We know that the sine of angle 2 must be, in this case, for this to be total internal, for the critical angle we must have an angle of refraction which must be 90 degrees. So we must have sine 90 degrees over the refractive index of medium 1, in this case, which is going to be the glass block refractive index 1.5. Okay, so we have put everything in our calculations. Now the sine of 90, if you notice, we put sine 90, that is going to give us 1. So we have now 1 times 1 over 1.5, which is 1 over 1.5 sine critical angle, or the sine of the critical angle is equals to, we have here 1 divided by 1.5, that gives us 0.666 recurring. Now take note, this is not the critical angle, this is the ratio, so we have to find the inverse. So we go now, the angle critical is arc sine 0.66 recurring. I prefer to use my calculator to do all this calculation and do one conversion, which could have been this way. Arc sine 1 over 1.5, and that is going to give you a much more accurate value. So you put here inverse sine, open bracket, 1 divided by 1.5, close bracket, and that gives us 41.8 degrees to 1 decimal place. Now that is the critical angle, that is not the solution yet. It says determine the value which angle B must exceed if D is to be totally internally reflected. So the angle B must be greater than 41.6. So angle B must be greater than 41.6, 41.8 degrees to get total internal reflection. It is that straightforward for these types of problems. Okay, so that's how we solve this problem.